Welcome back to Portainer in production. In this episode, we're going to take a look at continuous deployment with Portainer and the GitOps pattern. Let's have some fun. Hello, and welcome back to the Raw Code Academy. I'm your host, David Flanagan, although you probably know me from across the internet as Raw Code. Today, we continue on with our Portainer in production course. Again, I'd kindly like to thank Neil and the team at Portainer for sponsoring my time to put this course together. Thank you. Today, we're going to take a look at continuous deployment with Portainer using a Git repository. Coming from the Kubernetes ecosystem, we call this GitOps, where we store the deployment artifacts or manifests in a Git repository, so that we can see how they evolve over time, and that every change to our system is versioned and auditable. If you're not deploying to Kubernetes, GitOps has been a little bit more difficult. It may be that you require a configuration management tool like SaltStack to monitor a Git repository and run your deployment state. But there actually is an easier way. Portainer has a concept called stacks. Now, these stacks can just be YAML that you write into the Portainer web interface, and that will work just well. But Portainer has another feature where it can clone a Git repository and keep it in sync and deploy your stacks from there, giving us GitOps in environments that aren't Kubernetes. And as a recap, Portainer supports not just Kubernetes and not just Docker, but Docker Swarm and Nomad too. So let's take a look at how we can use the Git repository source for a Portainer stack to get continuous delivery in an environment that isn't Kubernetes. Let's have some fun. Okay, so where are we starting from today? Well, in our repository, available at github.com/rawcode/academy/Portainer-in-production, there is a directory called GitOps. Inside this folder, we have a docker-compose file. Now, docker-compose is still a fantastic tool. When it comes to local development, working with multiple services that need databases, caches, queues, there's no better way to develop than compose. So we're going to use that format today. I'm going to iterate locally on an EdgeDB deployment. Well, I don't need to iterate, it's already done. However, we'll make a change to show the entire process. So this compose file has EdgeDB configured as a service with the little bit of configuration that it needs to just work. We're going to assume that we're working on this. So we're going to run docker compose up. Now, it takes just a few seconds, but we will get a web interface that allows us to interact with our EdgeDB deployment. Now, it doesn't matter if you're not familiar with EdgeDB. It's just a relatively new database written in Python that is graph first with a rather interesting query language that allows you to select data across all the different types within the system. If we go to our web browser, we can go to localhost 5656/UI, where we can log in with EdgeDB and Portainer. It allows us to select a database. We can open a REPL if we want. We can browse the schema. So you can see the language here for defining our tables in EdgeDB is a type system, where we have a type of a blog post with a required property of ID, content, and title. We can also browse the data, where at the moment we have nothing. So we could say hello for the content with the title being title. Very imaginative. From here, we can review and commit our changes. And that's all you need to know about this local stack. So we're in a position where our Docker Compose does what we want it to do. We've tested the service does what we want that to do. So how do we get this to production? We don't just want to run it in our local machine. Now, production doesn't always have to mean a series of distributed topology-aware Kubernetes clusters with advanced scheduling and bin packing, with remote secrets management, and blah, 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 blah. A lot of the time, we're all building niche applications for a small subset of users, usually available internally, sometimes publicly, and we just need a container to run on a machine. So running Portainer with Docker on a machine gives you an immediate value add. It simplifies your life from Kubernetes. Now, of course, Portainer works really well with Kubernetes, and we're going to do a couple more videos on that in due course. But today we want to take the use case that I hope resonates with the majority of people watching this video. How do I run containers with continuous delivery and GitOps on one machine with ease? So let's take a look. The first thing we do is go to Portainer. If you watched the first video, you'll know that this is available for me on p.rawcode.academy, where I have a single EC2 instance running the Docker engine with Portainer on top. We can click on that environment and go to stacks. As you'll see at the moment, we have no stacks. So let's click on add stack and add our stack. Now I'm going to call this stack EdgeDB. Now we could use the web editor and paste our compose YAML here. We could upload it from our machine or even use a custom template. But today I want to focus on the GitOps model and continuous delivery. From here, you can add your repository URL. Mine is on GitHub at github.com/rawcodeacademy/Portainer in production. My reference is refs head main, and my Docker compose file is in the GitOps directory at docker-compose.yml. Now we're going to turn on continuous delivery by enabling the automatic update setting. We're going to start with the simplest solution, which is to turn on polling at 1 minute. We can force it to pull the latest image and force a redeployment. However, we won't need that last option today. If we need to provide any environment variables, perhaps to configure a new secret in production as opposed to what we use in dev, we can do so from here. Now we click deploy the stack. Sometimes it just feels too easy. So let's click on our stack and scroll down. We're able to modify the fetch interval if we're not deploying as frequently as we want, although I am going to use 1 minute today so we can actually make a change to this repository. It may make more sense for you to use 15 minutes or even an hour, or perhaps you only deploy once per day. That choice is up to you. Now, if we scroll down to the bottom, we'll see our containers. We can see now that our EdgeDB stack is spinning up. And if we click on that, we get all the benefits that Portainer brings, which is the ability to understand and visualize what is happening in our environment. Here we have the ability to kill, restart, pause, and remove the container. We can see that our container has been running for 1 minute, and this little green heart means that things are healthy. If we scroll down a bit more, we can see the output from the logs. And then we see the configuration in more detail. From here, we can see that the ports are configured, as we expected, the same as our development environment setup on ports 5656. So, scrolling through all of this, we have a degree of confidence that our application is running. So we can confirm this works by changing the URL to port 5656/login. From here, we get the EdgeDB login screen, which means our deployment was successful. So let's make a change to our stack and see it continuously rolled out in a GitOps fashion by Portainer. We can pop open our Docker Compose file, and let's say we're going to add one more service. We'll add an image of Nginx latest, and we'll map some ports. Now, we're not going to make this available in port 80 because we have some TLS stuff running for certbot. but we can make it available on 5657, and we'll redirect it to port 80 within the Nginx container. Now this is a contrived change to our Docker Compose file, adding an arbitrary Nginx, but your applications will be your services that you change. We can now go over to our terminal where we add our docker-compose.yml change. From here, we do a commit and say feature add Nginx. We now do a git push, and in 1 minute's time or less, we should see Portainer pick up the changes to our stack and add the second container. If we go back to our Portainer screen and to our stack and clicking on EdgeDB, and around, hopefully, 30 seconds time, we will see a new container added to this list. Voila, we have our second container. And of course, we can confirm one more time by changing 56 to 5657. And we have our Nginx. So Portainer makes it very easy to pull a Git repository for your docker-compose.yml and make all the changes in a production-like fashion, which is pretty neat. Okay, let's take a look at one more thing. When we set up our stack, we set the polling to be an interval. Now, I set it for 1 minute, and I sat here awkwardly waiting for the refresh to show you the Nginx container. Now, depending on your deployment velocity, and depending on what your project even is, you could be deploying 4 times an hour, 4 times a day, or 4 times a year. So polling may not be that effective. And instead, you may wish just to have GitHub send a webhook to your Portainer instance every time there's a change. And Portainer makes this pretty. And Portainer makes this simple. So let's make a final adjustment to our stack. We go into EdgeDB and we're going to switch to webhook. We're going to copy this link and click save. So let's add the webhook to GitHub. We go to our repository, which in this case is Rockwood Academy /Portainer in production. We go to settings and webhooks. From here we can say add, drop in the URL, and say we only want the push event. We click add. GitHub sends a test ping, which if we click on here, we'll see has a green tick. This means our webhook was successfully configured. We'll pop back over here and list the containers for our stack. So let's add one more service to our stack. We're going to copy Nginx, and we'll call this HTTPD, and we're going to run the HTTPD image. And we won't bother exposing this to the internet. Then we'll jump over to our terminal, where we can do an add, commit, and a push. Now if we pop back over to Portainer, right before our eyes, we see one more container added to our stack. So that is GitOps with Docker Engine and Portainer with Docker Compose. It's a pretty impressive setup, which will work well for the majority of projects, where you just need a few containers running on a Linux machine. You can configure it to update your stacks with polling or via webhooks, and you've seen just how easy both approaches are. So go check it out. Download Portainer. Remember, the business edition is free for less than 5 nodes. And if you've got less than 5 nodes, this GitOps model with Docker Compose is probably exactly what you need for production. So, go have some fun. See you next time.